Our Milky Way is under threat. Across the universe, galaxies are going dark, and scientists are trying to find out why.
Something is slowly drawing the curtains closed on the universe.
Why are the stars in our galaxy losing their shine? Will the Milky Way slowly fade to black?
If our home galaxy is getting dimmer, what does it mean for us?
Astronomers are now racing to unlock the mystery of why galaxies are darkening. Is there a link to massive bubbles of dust and gas that shoot out from the center of the Milky Way?
We had discovered something truly extraordinary.
Can the biggest collisions in the universe switch the lights back on?
We thought galaxy collisions would be very violent and destructive, but what we find is that they're one of the most creative processes in the universe.
Scientists are gathering evidence for a startling theory of how galaxies are born, live, and die. Our galaxy, the Milky Way, is just one of many hundreds of billions of galaxies in the universe. Galaxies are huge, glowing concentrations of gas, dust, stars, and planets. Telescopes capture breathtaking pictures of bright, shining galaxies millions of light years away.
There are a few things that make my jaw drop, like images of galaxies. When you think about how vast they are and just how beautiful, and also just how recent it is that we understand what these things really are.
The basic component that we see of galaxies are stars, and that's what keeps these galaxies shining. The Milky Way is an enormous disk galaxy, about 120,000 light years across, and it has several hundred billion stars in it.
In 2015, astronomers make a worrying discovery. They report that something strange is happening across the universe. Hundreds of thousands of galaxies are getting dimmer. Some have lost 50% of their brightness over the past 2 billion years. And the Milky Way is one of them.
This isn't just happening somewhere in the deep void of space in an unknown galaxy. This is our home galaxy, and anything that affects our home galaxy affects us.
The way that galaxies recycle their precious star-building material should keep them shining brightly. As some stars reach the end of their lives, they go supernova. This giant explosion catapults a huge wave of gas across the galaxy. This wave injects new material into interstellar gas clouds and compresses them to the point where gravity takes hold. Gravity pulls the material tighter together and triggers the formation of a new generation of stars. Over time, this process keeps the Milky Way bright as billions of stars burst into life.
To me, one of the most beautiful stories ever told is the cycle of star formation. So in a galaxy, you have these giant clouds of dust and gas that collapse into massive stars. Those stars then live their lives and blow up and distribute their material back into the galaxy for new stars and new planets to be made of. So that cycle of star formation is what keeps galaxies bright.
But it appears that something is going wrong with this galactic circle of life across the universe.
The shocking thing is that our own galaxy could be in decline, so the lights could go out in our night sky. Galaxies are huge systems of gas and dust and stars, so whatever's turning them off must be something major.
Why are galaxies losing their shine? And what does this process, called galactic dimming, mean for our own Milky Way? Astronomers believe that the heart of our own galaxy is a good place to search for answers. The center of the Milky Way contains the greatest concentration of stars. Focusing on this area gives scientists studying galactic dimming a huge sample size compared to smaller clusters of stars on the edges of the galaxy.
If you want to study the history of star formation in the Milky Way, why not look towards where there are most stars, and that's the center of the galaxy?
But astronomers face a big problem, seeing clearly this far into space from Earth. Thick clouds of dust and gas lie between us and the center of the galaxy. These clouds block the visible light that our eyes see. Infrared light passes through this dense gas. Astronomers use special infrared detectors to study objects that other types of telescopes cannot see. But the water molecules in Earth's atmosphere absorb almost all of the infrared light before it reaches the planet's surface. This reduces the level of detail that the telescopes on the ground see. Even telescopes on mountaintops higher than 16,000 feet above sea level struggle for a clear view. To overcome the problem, NASA and the German Aerospace Agency built this, the Stratospheric Observatory for Infrared Astronomy, or SOFIA for short. SOFIA is a modified Boeing 747 that flies in the stratosphere above the clouds and carries a high-powered telescope. With its 8-foot mirror and infrared sensor, the telescope sees past galactic gas and dust to detect objects far out in space. SOFIA looks through a corridor 650 light-years wide, right into the super bright center of the Milky Way. This has the most star-forming matter in the galaxy, so SOFIA's infrared sensors can count the number of newly born stars. The data from SOFIA, combined with the data from space telescopes in orbit around the Earth, builds up a super detailed image of the center of the Milky Way. SOFIA's observations confirm that the galactic center contains the largest and densest concentrations of gas in the galaxy. These dense gas concentrations should collapse to make new stars. The more gas that collapses, the more stars that a galaxy creates. But the telescope data shows that this isn't what is happening in the Milky Way.
As we look into the center of the galaxy, we see these dense, dark regions that should be forming stars, but for some reason, they're not. Something is damping down star formation in the heart of the Milky Way.
The gases left over from the death of one generation of stars should help give birth to the next generation. But SOFIA discovers that many of the giant gas clouds in the center of the Milky Way are not collapsing into new stars. Astronomers find that these gas clouds are giving birth to 10 times fewer stars than expected.
Though there are some regions that are very dense with gas and forming stars very actively, some places in our galaxy still host gas, and yet they're not forming stars at all. Without the light from these new stars, the galaxy is losing its brightness.
Stars are temporary things. They're born and they die. So, in order for a galaxy to stay the same brightness, you need to have a relative equilibrium with the number of stars being born and the number of stars dying equaling so that the lights don't really change. If we had an image of the Milky Way from a few billion years ago, what we notice is that this cumulative amount of starlight has dropped.
The evidence is clear. The Milky Way produces fewer stars now than it did in the past. And that is why it is dimming. Fewer new stars means that our galaxy is slowly dying. What is putting the brakes on star formation in galaxies like the Milky Way? Are mysterious galactic bubbles the key to solving what is killing our galaxy? Galaxies across the universe are getting dimmer. Telescope observations reveal that something is preventing the formation of new stars in the Milky Way.
Star formation is a powerful process. The scales are unbelievable, and yet all over the galaxy, things seem to be shutting down. Did something happen in the past, something huge, some cataclysm that actually shut off star formation? And can we find any evidence of this?
That evidence could lie in data from NASA's Fermi telescope. Fermi scans space for super high energy light called gamma rays.
The gamma ray sky is a completely different view of the universe. The Fermi telescope is able to witness the most energetic events that are happening throughout it.
The telescope discovers something incredible. Two superhuge bubbles of gamma radiation emanating from the center of our galaxy. The bubbles extend 25,000 light years above and below the spiral of the Milky Way.
The scale of these Fermi bubbles is enormous. They're roughly the radius of the galaxy, half the width of the galaxy. If you were to go outside and look up in the sky, they would cover 2/3 of the size of the sky.
Only the most violent events in the universe have the power to produce gamma rays, like supernova explosions and neutron starquakes. Neither is powerful enough to unleash the amount of gamma radiation that turns into the Fermi bubbles. So what made them? Scientists think an invisible monster at the center of the Milky Way could be responsible. At the heart of every galaxy lurks a supermassive black hole, a point in space so dense that nothing can escape its gravity.
From what we've observed, every galaxy has a supermassive black hole at its core. And there are at least 2 trillion galaxies in the observable universe. So this means there are trillions of supermassive black holes.
The supermassive black hole at the center of the Milky Way is called Sagittarius A star. It weighs the equivalent of 4 million suns. This black hole's enormous gravity draws in anything that gets too close. The energy unleashed when this gravity rips apart stray stars could unlock the mystery of what makes the Fermi bubbles.
Black holes don't eat like a nice, distinguished, gentrified person. They're sloppy. They're like the Cookie Monster. When a Cookie Monster eats cookies, more comes out than goes into his mouth. Well, supermassive black holes are just like that. Stuff is moving incredibly fast, approaching the speed of light, and the density and pressures are incredible. And so it's almost as if there are explosions in this traffic jam of material trying to get into the black hole. And so a lot of material gets shot out away from the black hole rather than ending up inside it.
The more massive the objects that the black hole consumes, the higher the densities and pressures around the black hole become, and the greater the amount of energy that blasts into space as gamma radiation. Scientists rewind the Milky Way's galactic clock. They predict when Sagittarius A star feasts on a meal large enough to forge the Fermi bubbles. Some scientists estimate that around 3 million years ago, Sagittarius A star draws in a vast amount of matter that flattens out into a huge, glowing, spinning disk. As the black hole devours this matter, 2 immense jets of energy blast out from its poles. These jets blast gas out of the galaxy 25,000 light years into space. The jets turn off when the black hole finishes its feast. All that remains are the Fermi bubbles we see today. Scientists think that multiple events like this one, throughout the history of the Milky Way, could unlock the mystery of why our galaxy is dimming. The reason lies in the huge amount of heat they unleash. Stars form when huge quantities of gas and dust collapse under gravity. The process triggers a nuclear reaction. Scientists calculate that this reaction happens only when the gas is cold.
Star formation is a battle between these two forces of gravity, which is trying to collapse the cloud, and its own internal heat, which is trying to inflate it. For gravity to win, for stars to get made, the gas has to be cool enough that it doesn't stay inflated, that it's able to collapse.
The jets that Sagittarius A star releases hurl some of the richest star-building material into intergalactic space. This superheats the gas at the center of the Milky Way. The clouds of gas become too hot to collapse into stars.
All of this heat and power and light and force would have stripped out all this material from the center of the galaxy, so it just would not have been available to form new stars.
A series of events like these, happening at different times in our galaxy's history, could put the brakes on star formation at the heart of the Milky Way. Telescopes look millions of light years through space at other galaxies. They discover that the damage Sagittarius A star wreaks on the Milky Way throughout its past is not unique. Astronomers observe 2,000 galaxies that show evidence of huge blasts of gamma radiation coming from the black holes at their centers. And the vast majority of these galaxies are now getting dimmer.
We see it in an enormous number of galaxies throughout the universe. Direct signatures of violent black hole activity and a depressed star formation rate. There's definitely a clear connection.
But do bursts of radiation from a supermassive black hole spell doom for a galaxy indefinitely? And do mysterious alien stars unlock how it might be possible to reverse galactic dimming? Jets that blast out from supermassive black holes kill star birth at the center of galaxies. They could explain why our Milky Way is dimming. Will the curtains close on our galaxy forever? Or is there a way it can get a new lease of life? Scientists believe a clue could lie inside a space rock that fell to Earth. In 1969, a meteorite lands near to the small town of Murchison, Australia, 100 miles north of Melbourne. It shatters into pieces, and locals gather over 100 kilograms of the black, smelly meteorite fragments. In 2019, scientists grind down a sample to analyze what it is made of. They get a big surprise. They find grains of dust from alien stars that died 4.6 billion years ago, before our sun was even born. These grains of stardust become locked inside space rocks through the star's never-ending cycle of birth and rebirth. Billions of years ago, an ancient star in the Milky Way reaches the end of its life. Chemical reactions inside the star makes it grow rapidly. It transforms into a red giant. The outer layers of the star shed grains of stardust. These grains travel light years through space and merge with the spinning disk of gas and dust surrounding newly formed stars. The stardust from the dead red giant combines with the material in the disk to make asteroids. It is a part of just such an asteroid that falls on Murchison as a meteorite in 1969. These grains of dead stars might reveal if galactic dimming, caused by blasts of gamma radiation, spells doom for galaxies like the Milky Way. Different types of grains come from different dead stars. Adding up the unique grains tells astronomers how many stars existed in the Milky Way at certain times in the past.
These little pieces of stardust inside this meteorite tell us the story of what was happening in our galaxy before our sun even formed. They're little tracers.
The stars that eject the grains found in the Murchison meteorite live for between 2 to 2.5 billion years. So, it is possible for scientists to calculate when these ancient stars were born.
By knowing that these grains came from dying stars, we can actually trace backwards in time to when those dying stars were actually first forming.
Scientists discovered that these grains come from different stars from all over the galaxy. But they share one thing in common. They are all born 7 billion years ago. Calculations reveal that the rate of star birth in the Milky Way at that time is double the average.
This was a beautiful and exciting result. It showed that the Milky Way experienced what might have been a sudden and unexpected burst of star formation about 7 billion years ago. And this might not have been a localized event, it might have been galaxy-wide.
These grains show that galactic dimming is not inevitable. Galaxies like the Milky Way experience periods of intense star building. These events counter galactic dimming. They make galaxies much brighter.
A galaxy is such a rich and complex thing. It turns out that its life cycle is not very simple. They grow, they change, they evolve. And in fact, their story may not be so doomed after all.
What triggers these sudden bursts of star creation within galaxies like the Milky Way? A clue lies in the findings from an observatory in New Mexico. This is the Sloan 100-inch telescope. Sloan's Apogee project studies hundreds of stars in the Milky Way simultaneously during a single observation session.
One of the most powerful things that we can do as astronomers is take a survey of the night sky, of looking at huge chunks of the sky at the same time and mapping out all of the stars there.
The light from a star reveals information about the chemicals it contains. Apogee analyzes this starlight to unlock the precise chemical makeup of thousands of stars.
So you take the light that any particular star emits, you break it up into a rainbow, and you can see the fingerprints of all the different chemicals in there, the ratios of them, how much there is of one thing versus another. Every single chemical has its own rainbow fingerprint.
The results from Sloan's Apogee project reveal that there's something very strange about the chemicals inside some of the stars in the Milky Way. Stars contain 98% hydrogen and helium, and traces of other elements like iron, magnesium, or carbon. Apogee analyzes the light from over 600,000 stars to decode the chemical signature of each one. It finds that nearly all stars in our galaxy, regardless of their size or color, share a common signature. But every now and again, Apogee finds a rogue star with a different signature. How is this possible? Astronomers studying these odd stars out come to an astonishing conclusion.
Their ratios don't match everything else in the Milky Way. By identifying stars that have a different chemical signature than other stars in the Milky Way, the implication is clear. These stars did not originate in the Milky Way galaxy.
If these stars weren't born in the Milky Way, then where do they come from? And do they unlock how to reverse galactic dimming? Astronomers discover that our Milky Way contains mysterious alien stars that were not born in our galaxy. So where did they come from? And what is their connection to galactic dimming? The European Space Agency's Gaia telescope finds a clue. The telescope maps the motion of over 1 billion stars in the Milky Way. It discovers that these odd stars out all travel on different orbits to stars that share the typical chemical profiles for the Milky Way. They circle the galactic center in the opposite direction to other stars and move on elongated, oval-shaped orbits. The results from Gaia lead to a startling conclusion. These alien stars come from a different galaxy. But how can a star jump between galaxies? A clue lies 250 million light years from Earth. This is a galaxy named ARP 220. It has one of the strangest shapes of any known galaxy in the visible universe.
ARP 220 does not look like a regular, calm, beautiful, majestic spiral galaxy like the Milky Way. It is this train wreck blob. It's an absolute mess.
Why does ARP 220 look so different to other galaxies? The answer is ARP 220 isn't a single galaxy.
The bent shape of ARP 220 isn't just because of aesthetic reasons. It tells us something about the galaxy's history. It appears to be the result of a merger between two galaxies.
The merger of two galaxies after a collision explains how alien stars can jump from one galaxy to another. The discovery of odd stars out in the Milky Way is evidence that our galaxy too is involved in a collision billions of years ago.
Now we understand that galactic collisions are responsible for these odd stars in the sky. They didn't come from the Milky Way galaxy. So it's an amazing thing to think that when you look up in the sky, some of even the nearest stars may have began their lives in an entirely different galaxy.
Astronomers believe that these galactic mergers unlock what triggers intense periods of starbirth in galaxies like our own. The clue is that merged galaxies like ARP 220 are some of the most brilliant objects in the universe.
There are some galaxies in the universe that are putting on a spectacular show. They're incredibly bright. Their name says it all: ultraluminous starburst galaxies.
The brightness of a galaxy like ARP 220 is a telltale sign that it is producing huge numbers of new stars. The raw ingredients for this starburst are the vast clouds of gas that wrap themselves around every galaxy.
When two things merge together, there's a lot of reproduction of stars. New stars are being born. Just like we had a baby boom, we have a star boom.
700 million years ago, two enormous spiral galaxies are on a collision course, stripping away their stars and planets reveals what happens when they collide. The galactic gas and dust compress in the collision. This triggers the formation of billions of stars. Over millions of years and multiple collisions, the two galaxies merge into a new galaxy that is incredibly bright, ARP 220.
So a galaxy collision sounds like a really violent event, right? But in fact, it can seed new life. Gas is the fuel from which all stars are born. So when you introduce new gas to a merging galaxy, you can form a new generation of stars.
observations reveal ARP-220's origin is not unique. Astronomers believe up to 80% of ultraluminous starburst galaxies are the result of galactic collisions. Could a cosmic merger be responsible for the epic periods of intense star building in the Milky Way's past? And when will the Milky Way's next galactic mega collision take place? Scientists are on a mission to discover how galaxies can reverse the effects of galactic dimming. The brightest galaxies in the universe reveal that the galactic collisions breathe new life into a galaxy. So when was the Milky Way's last major collision? Astronomers plot the positions and movements of both the old and new stars in our galaxy. They use this data to rewind time and reveal the event that triggers one of the greatest ever periods of star building in the Milky Way. Around 10 billion years ago, the Milky Way collides with a smaller, ancient galaxy called Gaia Enceladus. The impact compresses together huge clouds of gas. This gas collapses to make thousands of brand new stars. The Milky Way brightens as more and more stars form.
The past collision of the Milky Way with Gaia Enceladus might have introduced an enormous new reservoir of gas into our home galaxy, and that gas could have gone into forming a new generation of stars.
When you think galaxy collision, it sounds like something destructive. But in fact, when one galaxy collides with another, that's a harbinger of the creation of a brand new generation of stars. Our own sun may have formed when a small galaxy collided with the Milky Way billions of years ago. It's an act of violent creation.
A mega collision 10 billion years ago reversed the Milky Way's galactic dimming. Where else has the gas needed to make new stars come from since then? In 2020, astronomers using data from the Gaia space probe uncover a clue. Gaia spots a cluster of a few thousand bright young blue stars in an ancient outer region of the Milky Way. These stars burst into life along a stream of fresh hydrogen gas. Gaia follows the gas trail into intergalactic space to a cluster of stars outside the Milky Way.
Our galaxy is not alone in space. The Milky Way is surrounded by dozens of smaller galaxies. And where we have maybe 100 or a few hundred billion stars, these galaxies only have about 1 billion. It's like we're a whale in the ocean surrounded by a school of little fish.
The new star-building gas comes from the largest of these dwarf galaxies, called the Large Magellanic Cloud. The huge gravity of the larger Milky Way continually strips gas from the smaller dwarf galaxy. The new gas collides with the outer regions of our galaxy. Thousands of bright, young blue stars burst into life. Astronomers estimate that the Milky Way will completely tear apart the cloud within the next 2.5 billion years. Dwarf galaxies like the Large Magellanic Cloud keep the Milky Way topped with star-building gas.
The Milky Way isn't isolated. It has a lot of neighbors, and it's stealing gas from some of them. It's ripping them apart and incorporating that material into itself. And that's the material that may form new stars in the future. The Milky Way is literally sucking the gas off of its neighbors to keep itself alive.
Astronomers think that there is enough gas in these satellite galaxies to keep the Milky Way fed for a few billion years. But where will the critical supplies of gas come from once these smaller galaxies are exhausted?
We want to know what's going to happen to us, to our star, in the very distant future. And knowing the future of the Milky Way will help us understand what's going to happen to our home.
Astronomers scan the cosmos to identify where the Milky Way's next meal will come from. They discover that it is our own galaxy that might be next on the menu. The Milky Way has fed off the gas from around 50 smaller satellite galaxies for billions of years. But it might be about to meet its match. Nearby, on a cosmic scale, is Andromeda and its satellite galaxies. Andromeda has over 800 billion stars, more than double the number in the Milky Way. This juggernaut is hurtling towards us. The stage is set for a mighty cosmic showdown. When will this clash of the galactic titans happen? And what will it do to the Milky Way? Astronomers believe the Milky Way is destined to collide with our galactic neighbor, Andromeda. They race to discover when this mighty cosmic face-off will take place.
The Milky Way and Andromeda are two of the most massive galaxies in our local group, and we know that they're moving toward one another and will eventually collide. So what we want to discover now is whether they're on a direct collision course and they're headed right for one another, or whether they're going to continue to dance around each other for several billion more years.
Telescopes from around the world scanned Andromeda to unlock its speed and trajectory. They discover that Andromeda and the Milky Way will smash into one another within the next 5 billion years. The result will be a period of star creation unmatched in the history of our galaxy.
We now have the most accurate prediction of when this collision is going to take place. And when it does, it's going to set the skies alight because there's going to be a huge burst of star formation.
The massive sizes of the Milky Way and Andromeda give them huge gravity. The two galaxies speed towards each other at over 250,000 miles per hour. Their gas reserves smash together when they meet. This triggers a super intense period of star creation. Billions of new stars burst into life. The spiral arms of the Milky Way and Andromeda tangle together. They eventually form a giant super galaxy called Milkomeda.
What a sight that will be. I mean, it's beautiful enough going out now and seeing our galaxy as it is, but we're adding a whole other galaxy to our own. There will be more stars, more gas out there, more things to see, more structures in the sky. It will be fantastic.
Today, a drop-off in star formation at the center of the Milky Way means our galaxy is losing its shine. The creation of Milkomeda will throw this galactic dimming into reverse. This new galaxy will make billions of bright new stars in the space of a few 100 million years. But scientists believe that our galaxy will then move into the final stage of its life after this dramatic merger. The light from a billion new stars bursting into life so quickly blast away surplus gas. This prevents the birth of new stars in the future.
The formation of bright stars is going to drive out gas and dust. And then when the big stars start exploding, that's going to drive out even more. So this birth may just lead to the end of star formation in the galaxy.
We think of galaxies as these immortal structures, these vast swirling voids of hundreds of billions of stars that live for all of time. But in fact, it's not true. Galaxies change and evolve and eventually die.
Milkomeda will inhabit a sparsely populated part of the universe. There will be no nearby galaxies to feed from to rejuvenate the lost gas supply.
Once the Milky Way and Andromeda merge and form a new larger galaxy and has this huge burst of star formation, after that, things are gonna go a lot quieter because we're relatively isolated right now. It's just the two of us.
Milkomeda is condemned to terminal decline and extinction.
After the giant galactic fireworks show that will be the collision of the Milky Way and Andromeda, we'll live in this simmering ember that will continue to cool off for billions of years more. Ultimately, our existence as a civilization is nothing but a sentence in the book of the universe.
Astronomers are now unlocking the life story of our Milky Way. Mega bubbles of gas reveal how supermassive black holes generate heat that stops star birth and makes galaxies grow dim. Weird alien stars show how galactic collisions rejuvenate galaxies and make them grow bright again. Today, the Milky Way is passing through a phase of dimming, but the light show we see from Earth is still spectacular.
I want you to realize that we live in this tremendously fortunate time. Go outside and look at the stars. Feel this joy seep through you. You are standing in this wondrous moment. Enjoy it and celebrate it.
The Milky Way will enter a new stage of its evolution in 5 billion years' time. One final cosmic blowout before it slowly fades away into the darkness.